by social inferences is something that we do all the time. How do we investigate this in the lab? Well, social psychologists looked at this and devised a stimulus, a little video that I'll show you in just a second, that we also used in our experiment back in the 1940s. Fritz Heider and Marianne Simmel wanted to isolate this process of social inference, and they did so by making this very simple video. I'll start it now. That has no faces. There's nothing overtly social here. There's no people. There's no soundtrack. And if you were a participant in our experiment, we would just sit you down and simply tell you, look at this, just watch and see what happens, no other instructions. And when it's over, just tell us what you saw. And what you see on the screen here are these three geometric shapes moving around, and they move around and do various things. The actual video is a little longer, a little slower, and you don't have me talking in the background to distract you. If you saw that, you would produce a description that runs something like this, that's notable for the fact that there's a story there. So people automatically imbue this with social meaning. They see a box, there's something going on, certain of these characters are being chased, some are scared, some are happy, and of course we can quantify these. So all these red words that you see here are words that are brought up by the social inference process, words about goals, intentions, emotions, and so forth. And we do this automatically. In a sense, you could think of this as a social illusion. It's like the illusions that Marcus Meister showed us, more complex, but it's a social illusion that illustrates our propensity to anthropomorphize, which is something we do all the time. We see faces in clouds, we get angry at our laptops, and you see social meaning in little geometric shapes moving around. Now, the interesting experiment that we did is we showed the same video, did the same experiment in a very rare patient known as subject SM, who has lesions, damage to a particular part of the social brain. She saw the same thing, and we asked her, what did you see? And she said the following, I'll just read it with you. She said, okay, so a rectangle, two triangles, and a small circle. Let's see, the triangle and the circle went inside the rectangle, then the other triangle went in, and then the triangle and the circle went out and took off, left one triangle there. And then the two parts of the rectangle made like an upside-down V, and that was it. Now, this would be very difficult for you to produce as a description of what you saw here. This is geometrically accurate. This actually happened, and it illustrates important points, which is that there's nothing wrong with this patient's vision. It's not that she has blurry vision. She saw what was happening. She encoded it into memory, and she could tell us about it. So perception, memory, and language are intact, but she fails to be able to link what she sees here with inferences about what she cannot see. Now, where's the lesion in this patient? It's that orange area on the far right of the social brain. These are two structures, one on the left, one on the right, roughly in where your ears are, a structure called the amygdala, which is Greek for almond, that my lab has studied in great detail. It's probably the structure that's been studied most with respect to social neuroscience. And it's ideally positioned to mediate this process of social inference that I was speaking of. So it gets input from high-level visual parts of the brain, like the face patches, as Dorit Tsao told you about. It gets that as input, and then it's able to associate that visual information with value and with all the inferences that we make about that stimulus through its projections to many other brain structures, for instance, in the frontal cortex. There's a wealth of evidence implicating the amygdala in social behavior.